My name is Peter Nielsen. I am the Director of Channels here at WhiteSource for the EMEA and APAC region. We lovingly call it the international space. And today we've got a really interesting and very different type of webinar. It's not going to be completely full of PowerPoint slides. There is an active and live demonstration halfway through that will take you through the technology in depth. And really what the purpose of today's conversation is to show you what it is that we do, how we do it, and why you should be considering it. On the call today, I have two speakers. If we move on to the next slide. Our two speakers today are first and foremost an internal TrustWave resource. I'll hand it over to them shortly. And then secondly, one of our trusted partners in the EMEA region, Logic Technology. The reason why we're doing this today is not just as a demonstration of what our technology is. Furthermore, it's really an in-depth demonstration of how we as an organization work with our channel community. We have very, very select few trusted partners that we work with, and Logic Technology is an excellent example of this. So today you will also hear from them, who they are, what they do, and why they work with WhiteSource as well. So without further ado, I'm going to hand it over to Luke for him to do his introductions and to explain why he is on the call today, and he will take it from there. Luke, over to you.
Brilliant. Thank you very much, Peter. So welcome everybody and good afternoon. My name is Luke Brogan. I'm one of the solution engineers here at WhiteSource. So dealing with all the technical elements and making sure we drive obviously the biggest value for our prospects and our customers. But just as a short introduction, I've been in the IT industry now for just over 11 years and been very fortunate to work with some major brands and ones which actually relate directly to the IoT space as well. So predominantly in manufacturing, spent quite a few years at BMW Group and more recently at Arrival, so electric commercial vehicle startup. And as you'd expect in that space, in the operational technology sector, you know, dealing with many different IoT types of deployments, whether that's quality, logistical or technology tracking systems. Pretty much most of my background has been in that operational technology space, and more recently working at a vendor like Beyond Trust and WhiteSource. Over to you, Gevorg.
Thank you, Luke. Hello to everyone. Thank you for joining us today. My name is Gevorg Melekjayan, and I'm the product manager for WhiteSource software at Logic Technology. And it's a pleasure to join forces with WhiteSource in providing this webinar to you. So when we go to the first slide, you'll see that an overview of the topics we will cover today. We will discuss firstly the application security testing tools pyramid, the application layer security, impacts of supply chain attacks, API security, ransomware, and IoT, the OSS challenge, and finally, shifting left 5 steps to securing your software development lifecycle. So in today's presentation, we will try to present a more secure, efficient, and productive method of managing and overseeing the open source security and compliance within your software development lifecycle. Within IoT, security risks are increasing as products and services are more and more personalized. And IoT also permits companies to continuously capture huge amounts of data about the customer in real time. So by leveraging the analytics derived from large volumes of IoT device generated data, organizations gain insights on the performance of their business systems, operational processes, and of course, customer experiences. Some examples of such IoT devices applications, which are tailored to customers are, firstly, IoT technology in the financial services sector, which is used to build a high resolution image of credit risk. Consumers using wearable and car-based IoT apps to carry out various transactions or signing up for financial services. Home devices such as smart meters that can propose special deals to homeowners based on energy consumption in a certain time frame. So the IoT infrastructure must nowadays support many different devices with most likely different communication protocols. These devices constantly have to evolve and become more secure along the way. Therefore, a highly flexible architecture with low development times supported by different framework tools is essential. So just to give you a short intro on logic technology, for almost 30 years, our goal is to make the life of software, hardware, and system engineers easier by providing them the tools that will help them become more efficient, productive, and most importantly, will increase the security aspect in their daily software development. The values we add to development teams are based on 4 pillars. Firstly, accelerating development. So we reduce the overall time required to develop, expand, and maintain a product or application during its entire life cycle. A few examples are our build time optimization tool, a DevOps application lifecycle management tool, and of course, software composition analysis by WhiteSource. Then increasing reliability. We also help companies to make their applications more reliable and their data more secure. For this, we have high performance file systems or deterministic database systems for mission critical applications. Then strengthening security. We aim to increase the overall security level of software by way of code coverage, software composition analysis again, or functional testing of MATLAB Simulink models. And the last pillar is ensuring compliance. We help customers enforce standards compliance through integration in their DevOps cycle by way of code coverage tools and software composition analysis. And now I will hand it over to Luke.
Brilliant. So in terms of just taking a step back and taking a look at the whole AppSec testing tool pyramid, as we like to call it here, represented obviously by the pyramid itself. The area highlighted there at the bottom is really where we specialize in software composition analysis. And we will dive obviously much further into the technology, the risks which are addressed, and obviously the value which is added by using a technology at WhiteSource. But with any building, obviously we need solid foundations before we can go ahead and add the additional floors to build either a large building or even a house. The foundations have to be robust and reliable. So what we have here is a load of different test tools which can be utilized to secure your application. And starting off at the bottom, we have static application testing. This is really where the tool has access to your source code and repository, and it can do a generalized scan to detect weak application programming or any known vulnerabilities or issues which may exist. The opposite to that is a dynamic application security testing, or abbreviated as DAST, and this is effectively the outside-in test methodology. It requires more setup time and configuration, but it's more realistic in its approach. The fact that you are testing like the public APIs and the way the users will interact with the application, we have a much more secure and robust test case which is presented to the users. Finally, on the bottom right, we have database security scanning. So making sure obviously all the data which is stored is obviously encrypted, but as well as all of the transactions which take place, getting and putting that data into that store. Now, each key area here has its own talk track. You can talk about each key area here in lots more detail, but it's just to generally show that this technology is very complementary to your overall security architecture. And once you mature in the key areas at the bottom, we then have the capability to move forward in the more specialized areas to get that security coverage.
So the application layer is where users interact with your apps, so its security should be paramount. Securing applications can be a struggle at best of times. Today, developers need to ensure that every level of their applications are audited for and protected against common vulnerabilities. In recent years, we have seen that much of the focus has been on ensuring the resilience of the technical systems that make up applications, such as secure network protocols and cloud native app security. There is, however, another aspect of web application security, which is often overlooked, which is the way that users interact with your apps. Securing this aspect of your app is just as critical as ensuring that your backend systems are secure. So why is the application layer then the most vulnerable? Applications constitute the largest attack surface of all the layers in the enterprise stack. In addition, they are the hardest to defend because they are the most accessible and most exposed to the outside world. And finally, the amount of data that passes through the application layer makes it highly attractive to malicious actors. One outcome of the 2020 global pandemic was that organizations have been forced to reassess their security strategies and infrastructure. In today's incredibly diverse software ecosystem, the challenge becomes protecting all your endpoints when they can be basically anywhere, including on devices you don't control. So think of anything that's in the cloud. As digital transformation accelerates, organizations are moving more and more systems to the cloud, which again requires a reimagining of the security paradigm. Traditional approaches to security are being challenged, but you don't need to be left exposed. So more than ever, security tools are focusing on both guiding development, so developers create more secure code, and giving advice on how to remediate vulnerabilities. In essence, what we're seeing is security shifting both left and right so that the entire development process is fully merged with security.
So just putting this into some of the elements around what we've heard in the media and some of the publicity around these types of attack. You know, I'm sure most people in the audience today have heard obviously what happened with SolarWinds and other sort of leading technology partners. So supply chain attacks can happen to pretty much anyone. The major issue here is we trust by default. So whenever there's an open source component being consumed in an iOS application or a web-based app, you automatically trust that source. And if it was to be hijacked, manipulated, or changed in any way, then it will obviously or could affect your application as well as the data stored within it. The example I'd like to briefly mention is around SolarWinds. I think this was very, very complex in terms of its design and obviously a highly targeted attack. Now, what was special about SolarWinds was the fact it's a supply chain attack. The customers making use of the Orion monitoring product are told, as always, with any DevOps or operational IT expert, that you should stay on top of your updates. Your firmware, your patching, etc., should always be close to the release as possible. So you have not only the latest features and functions, but also that additional security. If there's new exploits, we can patch them and deliver them as an update. And that's exactly what happened here. The update supply chain was compromised internally at SolarWinds, and then updates or legitimate update services were then pushed out to customers where the attack could then take place, and then it could be effectively switched on, and then data could be extracted from that given customer's environment. And we can go one step further than that. Not only was this a trusted party, a trusted update process, second to that, the data obviously going out of these customer environments were also completely masked. In terms of when you inspect the TCP/IP traffic, it looked like legitimate usage analysis and legitimate SolarWinds data. So even at that level, the attackers went to very, very high amount of detail to ensure they could go undetected for very long periods of time. And even today, there's not exact numbers to exactly how many people were compromised and exactly how much data was extracted from these customer environments.
So whether you have a web or mobile app connecting to your company, customers, stakeholders, partners, or investors, your client side of the app interacts with the server side via the application programming interface, also known as API. This means API security must be airtight and robust in design, architecture, and process. After all, it's the security ecosystem that would safeguard the data of your organization and your customer and be future ready, so to say. By using APIs, you may inadvertently open up the door to all of your corporate data. So API's goal is to connect and let the client side interact with the server side to transfer data safely. However, APIs can be misused during these data exchanges. Here's where data breach attacks and hacks happen. It exposes your personal, professional, financial, medical, and private data, leading to a loss of credibility and breach of trust with your customers. However, it may also bring benefits to the table, along with playing a major role in software and application developments. According to Gartner, by 2022, API attacks will rise considerably for enterprise application data breaches each year. Attackers have doubled their activities during the COVID-19 pandemic and managed to exploit every possible avenue to spike API attacks, claiming victory over vulnerable data across the globe. In April 2020 alone, this survey found a 667 increase in the malicious phishing emails sent by hackers impersonating the UK authority, CDC, and WHO during the pandemic. So you can think of APIs as the connective tissue linking ecosystems of technologies and organizations. APIs allow businesses to monetize data, form profitable partnerships, and open pathways of innovations. Using APIs, organizations are able to expand into new ecosystems. Unfortunately, many still struggle to secure these APIs. And in today's era, cybersecurity and data breach due to API is taken very seriously. The damages to an individual, organization, industry, or the economy as a whole can be devastating. And not a day goes by where we don't use apps and APIs for emails, shopping, or banking transactions. So all this brings us to the big elephant in the room. Is your API safe enough? And are you protected from API security attacks? So if we move on to the next slide. The open source software that the vast majority of organizations include in their critical applications is vulnerable to exploitation from threat actors taking part in its creation. That's the message from security professionals who point to the nature of open source projects and the unreliability of the code as a real threat to enterprises. Once implemented into an open source project, criminals have a wide range of options, but however, within a narrow window, whether it's a backdoor keylogger or Trojan or of some sort, it needs to net them something valuable quickly, or they need to do it in a way so they remain undetected. The combination of flexibility and availability makes open source project hacking an opportunity that apparently criminals are willing to seize. In almost all open source projects, contributors must have their work vetted by other members before the code is accepted as part of the project. Therefore, the level of review varies depending on the individual's reputation. So as they become more trusted, fewer layers of review may be required, especially in the larger, more well-known open source projects, such as major Linux distributions. The procedures are well-defined and the labor pool large enough to enforce those procedures on a consistent basis. In August 2016, we have seen that 2 UK researchers demonstrated the world's first ransomware attack targeting IoT devices at DEF CON. In this case, it was a Nest thermostat. Obviously, there are no files or data to block access to. So what does the ransomware do exactly then? It takes control of the thermostat itself. This might not sound very worrying at first, but as the program raises the temperature to 99 degrees and demands a 1 Bitcoin ransom every 30 seconds, this is surely something to be worrying about. The thermostat in question is basically a Linux computer, so the ransomware exploits an open source component vulnerability to take control. With the ransomware making its first IoT appearance, could this be then a sign of things to come? And how can we make sure to block open source vulnerabilities as early as possible in the software development lifecycle?
So just putting that into sort of facts and figures really, into the risk associated with open source components. What we have on the left-hand side is different software architectural styles, and then the amount of millions of dollars which are used to obviously perform research and development and build that solution set. So as you can see quite clearly, in the 1970s and the 80s, a lot of software was homegrown and organic. So we're looking at sort of C, Fortran, maybe COBOL. There weren't open source components to use or anything to leverage off the shelf. Everything was built in-house from the ground up, very bespoke, and obviously took a lot of time, but obviously we had a robust solution and grew from that scenario. More recently, sort of in the 90s and early 2000s, a lot of things shifted to what we call on-prem and mainframe styled computing. So virtualization was becoming more popular, and obviously mainframes for high compute sort of tasks. But again, open source was relatively new and up and coming for many applications, and would really drive the innovation and speed of development, which led into the SaaS era. So if we look from the mid 2000s, obviously till more recently, SaaS has pretty much exploded in the industry. You know, many people now utilize it, and it's just in essence an application which is sat on the internet. So very public facing, but leveraging lots of open source components for basically that DevOps innovation to basically build and deliver products as quickly and as easy as possible, with obviously that highest level of quality as well. But as we can see, that exponential shift in the last sort of 5 years, especially around SaaS, that almost directly correlates to the amount of public breaches which have been disclosed in the last sort of 10 years. So on the right-hand side here, we have pretty much all the major breaches which have happened to industry leaders and different technology vendors. And we can directly correlate, as more open source components and applications are built, there's a much bigger attack surface, and potential for these highly sophisticated target attacks increases as well. So just to set the scenario, really, what I've done here is the ability to understand the challenge of that open source component consumption really is just asking ourselves a set series of questions. And these are things I've seen from many of the customers which we've worked with. But we've got the question and obviously the persona alongside that. And what I see very often is, for any given application we have, how many open source libraries are currently in use? What is the software bill of material for any given application within a company? And you'd be very surprised to hear that a lot of companies either don't have this, they don't know the open source makeup of their app, or if they do, it's a very manual process. So it's a spreadsheet, and a developer or a DevOps engineer might walk through the code, which is very, very time consuming and obviously prone to human error. And really what we want to do is free up that time for the developer to do what they do best, which is obviously creating that application. So typically product owners need to know that information about the software bill of material. But then once we have that information, what libraries are up to date? We have libraries at a point in time when we built the app, they were the latest version, but they can quickly fall out of date. And this could leave either broken areas of the application, or more importantly, insecure configuration or vulnerabilities which may pop up. A lot of the time when we perform a scan, we detect vulnerabilities, some more than others, but the one typical question we get usually from the developer community is, okay, which ones are actually effective? If you were telling them there's 100 vulnerabilities here, are they all public facing? Can they be utilized within an attack? And it's a very valid question. So we'll dive down into White Source Prioritize and how we can do data trace analysis to work out if any given procedure or function is vulnerable and being presented in your application. There's some other things around multiple versions of the same library. So this is fairly common. If we have a contractor or a team, growing in terms of users and developers contributing to the product, we might see multiple versions of the same library, like jQuery, for example, could be deployed multiple times. And obviously that brings inherent risk of different versions and additional attack vectors. Finally, at the bottom, in terms of larger organizations, we can often see a compliance team or compliance management. And it's quite an often overlooked area, really. Are we using commercial friendly licenses for our open source software? Now, the big one which we typically avoid, especially for commercial usage, would be those GPL style licenses. But if you're not aware of your bill of material today, then it's very hard and a very manual process to work out what types of licenses are being utilized today. So the ability to then shift left and fix production environments, reduce the vulnerabilities and license compliance, and increase security early on, we can do that obviously with the white source solution set. And that's very much what we specialize in, the software composition analysis space. And just a couple of metrics here to explain sort of who we are and where we've come from. We've been in the industry now for over 10 years, so lots of experience in the software composition space. We're lucky to have over 1,000 customers utilizing our products today, which correlates to over 1.3 million developers protected using white source technology. And it's great to see those numbers grow because we know the significant value we add in terms of keeping those secure. 25 of the Fortune 100 are also using us. And as you could imagine, within this software composition space, we're seeing rapid growth in terms of not only open source usage being utilized more and more, but also the understanding of the risk that comes with this default trust. So we've seen obviously huge growth in this space as well. So just to back some of that up, obviously we have all of our customers currently on the left-hand side, or a subset of our customers. One of the largest ones to date would be Microsoft, with over 50,000 developers being protected. But what I really like about the list of brands here, which we work with, is the diversity. You know, we don't only work with software vendors, but it could also be pharmaceutical, manufacturing, leisure and tourism. You know, the list really goes on. And the diversity of the requirements is also very significant. We work with teams of 10, 20 developers, all the way up to the big players such as Microsoft, with over 50,000 people in the organization developing and contributing to that code base. Just on the right-hand side, we just have the latest Forrester Wave report. This is a report released every 2 years to basically look at all of the major vendors within the software composition space. We're proud to say that for the last 2 reports, we stayed within that top right quadrant. So a very strong current offering in terms of the solution set, but also we pride ourselves on having a very firm strategy moving forward. So understanding obviously that marketplace and having the roadmaps mature enough where we can obviously be involved with our customers and solve those issues as we work together. There is a report available, and if you just Google that, you can take a look at the analyst's view on the white source solution. So that's pretty much everything for today's PowerPoint, but what we'll do now is break out into an interactive demo. So we'll take a look at how you can shift left. So again, fixing obviously production and your pipelines, but really preventing any issues from ever occurring. We'll take a look at those 5 steps in order to secure your environment, and obviously the benefits that come with that. Obviously dramatically reduce cost because we're fixing it earlier, and therefore much higher quality product as we ship that to a production environment. So if you do have any questions that pop up halfway through, feel free to drop it into the chat window. We'll keep a monitor of that, and Peter will cast an eye over. So as they come in, we'll try and answer them in real time. So what I'll do there is just get rid of PowerPoint, and I'm going to head straight over to Chrome and just sign into the web browser here. Before we take a look at the white source UI, I just wanted to start really with step number 1, which is the research and development phase of a new function or procedure for your application. So if we just head over to the demo area here, go to packages, head over to Stack Overflow. Now, if you imagine I'm a developer working within Python and I'm involved in a sprint where there's a new feature required, I think a lot of people have used Stack Overflow before to copy and paste code, but what's important here is we can protect the developer from literally the earliest phase of where you search the internet for libraries which may solve your problem and obviously speed up development. So what we're using here is White Source Advise, which is a technology built into the browser in form of an add-on, and it can scan any given web page for any open source component. Now, this post is over 8 years old. It's still very valid, but obviously the packages which are being referenced are obsolete. They're very much out of date. Now, straight away from the developer's workstation, they can see before we copy and paste that code into the IDE, we can see the version, license, the fact it's out of date, but most importantly, the list of vulnerabilities associated to that version of that library. Now, this is a very early warning detection system, so you can still obviously copy and paste this, but what it does is ask the developer, like, are you sure this is the correct version? Are you violating any policies which have been set, such as not to introduce any vulnerabilities which are known, but also the projects where that library might be utilized today. Because we have that software bill of material, we can tell you for any given component and version, if any of your colleagues or developers are using that component today. And just by having visibility of that, you can then speak to them and find out how that's being utilized and if it's doing what it should be doing in that scenario. So that's very much the first step: protect the browser, protect that research and development phase. Secondly to that, then we move on to the IDE. So we copy the code from maybe another public website and we paste it into our project, which we may have on screen here. This is just a Node.js example, Node-Goat, which is a vulnerable project, but we cater for many different IDEs, whether that's Eclipse, IntelliJ, PyCharm, Visual Studio, and we can scan the project in real time and give the developer all of the problems which may be associated to that project. And just like a spell checker, we will underline that in red, and we'll provide a one-click fix where available if it's simple, such as updating the version of that library. If you are on the latest version and there is still vulnerabilities associated to it, then we do have a dedicated in-house security research team who can write workarounds, certainly for the most common libraries. So if that's a more complicated fix, then you'll be redirected, obviously, to the White Source website, but at least keeping you protected and providing a workaround until that library is fixed. So once the IDE step is then completed, we typically then commit code, obviously, to the repository. So again, in terms of integration, Bitbucket, GitLab, all the major vendors for storage there is compatible. So if we just do a search again for WebGoat as a project, this one is a Java example compiled with Maven. But what we have here is White Source already integrated into the solution. And straight away, we can generate an issue list based on your organizational policy. So what I've set already is trigger any medium or high vulnerabilities to be listed here as an issue. And we can obviously look through these as code is committed, and obviously those checks run in real time. We also cover infrastructure as code. So if you have any Terraform or Helm chart configuration, we scan that for inherent security risks, such as public buckets or unencrypted data, which may be stored somewhere in that environment. So we detect those in that. And finally, in terms of license policy, if you are blocking your GPLs or maybe a certain type of BSD, then those could be flagged up for review here as well. The most important thing to note is this is where the enforcement stage comes in. Very much with the browser integration and the IDE, we are recommending developers to review and research that, but we're not enforcing them to make changes. The main reason for that is obviously flexibility, And secondly, you might be working on a pen test where you require a known vulnerability to be introduced in example. But very much at the repo stage, we have the ability to enforce obviously things to raise issues. And then in the next step in the pipeline, we can actually break build so artifacts aren't pushed into production, for example. But in terms of the automation here, we've already done the detection, and now we need to look at remediating that risk. So what we can do here is take a look at some of the pull requests which have been raised. We can dive down into this one here where JSoup is going to be upgraded in order to mitigate those vulnerabilities. Now we can see the change number from 13 to 14, but a question which I usually ask a lot of being in IT operations is how do we know this change isn't going to break a dependency or cause issues elsewhere in the application? And we do have a solution which covers that. This is called Merge Confidence, which you see here on the screen. And what we've done with Merge Confidence is aggregate the data set for JSoup or any given library, and then built a maturity model around that. So because JSoup is used millions of times out in different projects, it's also been updated many times as well. So what we've done is aggregate that update process and just put it into some key metrics. The first one is obviously the age of the pull request. So you can see if it's new or very mature. You can see how many users have adopted this PR and obviously merged it into master. We've also calculated the subsequent pipelines, if they're still executing and still healthy. And then we have an overall confidence level. If this is high, then we might have to do a little bit of research, but we can probably merge it in with that high degree of confidence. But if it's low or neutral, because it's a new fix or because it's known to break things, for example, which does happen, then we might need to do much more due diligence, or we might test that in a segregated environment. But either way here, we can see the PR has been raised. We can automate its merge. And if you do want to find out some more information about why this vulnerability occurred or the suggested fix for that, that's also all available in the repository integration. So you don't need to learn the white source tool or the white source UI. All the data is already here for us. Finally, then, we typically have the pipelines. So if I just go to the CI/CD area, again, support for many vendors. The technology is actually agnostic to the vendor or the pipeline vendor because of the architecture. We'll take a look at why that's the case in a minute, but we'll dive to just Azure DevOps to begin with. It's just the nicest one to use, I think, very clean and easy. So we'll head over to our pipelines, head over to NodeGoat again, and we'll just take a look at the YAML configuration in how this scan is taking place. And really, it's only 3 steps which we need. The first one is to curl or download the latest agent. We then set some environment variables. And then finally, we execute the scan to take place in that pipeline. So 3 very easy steps, not very complicated and completely agnostic to any vendor here. So it makes it inherently very, very flexible. Now, the unified agent is really where the technology lies. This single lightweight Java agent will interpret your environment or your directory to scan. We have support for over 30 different package managers like your NPM, Maven, and loads of other examples for your different technologies which are covered. But it will also iterate through the directory structure, pick up any loose source files. And what it's really doing here is generating a list of SHA-1 values. These SHA-1 identifiers are used to look up against your open source components. So the only data we're sending to white source to contrast and compare are these SHA-1 IDs. So we never take any proprietary code or any private code there. We're only simply comparing that SHA-1 value to our vulnerability database. Just some background about that vulnerability database. Because it's been around for over 11 years now, it's very, very mature in detection. And just to give you an idea of some of the sources here, we use obviously the National Vulnerability Database. We also use CVEs, but we have our own in-house threat research team where we have the ability to create our own vulnerability IDs as well for the NVD. So that's obviously of significant importance. Now, the environmental variables, which we've set here, are just some examples. It's very, very customizable in terms of the behavior of that agent. And I appreciate the API key should usually be stored as a secret, but we're just demonstrating that here to show you what that configuration looks like. And then finally, if we just step back and go to the latest execution, we can see there's a white source tab at the top. We can click on that, and we effectively have all of the information we need to make a decision or to investigate any vulnerabilities or licenses which have been discovered. So again, the emphasis is you don't need to learn white source technology or the white source UI. Pretty much everything you need is integrated into the tools and methods and processes which you already use today. And then just to wrap up finally, we obviously do have that dashboard view, which is here. We can sign on with local users and groups or leverage SAML integration for your identity provider, whether that's Azure AD or Okta. But really, this is a great security analyst dashboard where we can receive what we have now is effectively a 1,000-foot view of the organization. And for any given application or pipeline or repository, all that data is effectively aggregated into the view which we see here. We have many reports available on the platform, license due diligence to give you a list of the highest risk licenses which your organization has. And we also have risk reports benchmarking you against industry standard averages for how you compare against the oldest versions which are being executed today, the total number of vulnerabilities, and those key metrics for the company. But the final piece I'd like to just show you is under the products and projects area. Just in terms of the architecture, a single product, or what I like to look at as an application, can have many sub-projects. So the product could be sort of like an IoT example, and then the project would be potentially a couple of repositories which belong under the project, but it also could be the different pipelines and the varying technology you use to deliver that unified product. So it's a one-to-many sort of ratio at that point. If we just dive into the IoT examples, this is just an example project really of where I've scanned an embedded Linux distribution. And this was done with the unified agent, I believe about a week or two ago. Only takes a couple of 1 or 2 minutes to scan, but straight away we have that software bill of material. So we can see all of the open source components for this lightweight Linux distribution. But we can also see some other key metrics like the new versions which have been released. So for software quality, we might need to dive into those and look at upgrading our packages. We also have libraries here which have multiple licenses associated to them. So if we take a look at one library here, we can see there's 2 license types. And what we can do is dive into that and find out the copyright information and why it's been viewed potentially as high risk in this case here. But either way, we've got the information here to make an informed decision. And then as we've recommended, you can then override these license types listed here to get your desired outcome. If we go back one more, then finally we have the security aspect. So we can see there's 10 vulnerabilities within this project, which correlate to 2 libraries. So we can see 2 of the 20 libraries are currently vulnerable in this application. If we click on the vulnerability list here, we then have the CVE values, obviously the libraries, and the projects where that's being utilized. But if we pick on any one of these, Bootstrap, for example, then we have a description, the obviously CVE value and score, and then the top fixes around remediation. So pretty much everything we need to get information and then either fix that manually or configure this to be automatically fixed either in the repository or the pipelines. Brilliant. So that's pretty much everything I wanted to cover in the demo. I will check the Q&A to see if anything's come in. But Peter, I don't know if there's any questions at this point.
Yeah, that is right. Thank you very much. Luke, we do have a couple of questions here, if that is okay.
Yeah, absolutely.
Great. Thank you very much. Good presentation as always. And thank you, Gabor, also. So if we just fire, there's a couple of good questions here. Actually, I've got 3 so far. So if I start with the first one, and some of these you may have touched upon, and that's okay. Maybe just reiterate as well, as we've got a little bit of time left. So first one is, how does WhiteSource integrate with existing applications, pipelines, and repositories?
Yeah, absolutely. That's a great one. I can pick that one up. So yeah, many of the proof of concept environments and prospects we work with have mature or running applications in production today. That's obviously very, very common. And really, we can integrate at many points of the SDLC as we saw in the presentation. But the key areas would be obviously the repository and the production environments. We can scan those usually in a separate environment, so we can run them in a copied pipeline or something like that to generate the results. And then once we have the results, we can work through them together and obviously look at remediating them. But in essence, it's just running the solution, I think, initially, getting it, the architecture and introducing the technology. But then it's very easy to get up and running in that production environment. So you don't need to build it in from the start. You very much bolt on to any technology or SDLC process we need to today.
Excellent. Thank you very much. The second one we have here is, do you have any reports that make recommendations around risky licenses such as GPL?
Yeah, absolutely. So in the WhiteSource dashboard we saw lastly there, one of the reports actually is the due diligence one, where for any given application or scan which has taken place, we will calculate the risk score associated to the license and library for that environment. It's based from 0 to 100, 100 being the highest risk and 0 being very flexible in terms of how you consume that. Then what we can do is run that report and see all the projects and products with high risk licenses. And usually you're looking for those GPLs, and either we switch the library out or we actually look at removing that altogether in most scenarios, just because of the inherent risk of that library type.
Excellent, thank you very much. And then the final one that I've got so far is, why is, for example, scanning the repository not enough for vulnerability detection and license compliance?
Yeah, absolutely. So what I think when we look at the SDLC as a whole from end to end, so the research and development to production artifacts, however you deliver that application, repository scanning is obviously critical. I think it's very much in the middle of the software development lifecycle in my version, or the industry version. So that's where we can enforce obviously the policy and the business logic to keep safe. But it's not enough in terms of recovery. If we are introducing lots of vulnerabilities daily and we're relying on the repository to fix that, we have a single point of failure. It's a single resource and it's a high risk strategy. So what we want to do is actually shift left as early as possible and follow that methodology, because it goes back to the prevention is always better than recovery. If we can not only educate the developers to use the browser integration and the ID integration, which is very seamless, and block those risks early on, then we much less reliant on that repo integration. So I think it's all about end-to-end security, especially in the software development lifecycle, to give you that complete coverage and better quality of software and more robust and secure as well.
Excellent. Thank you very much. Before we close out, just want to thank everyone. And just before, I have a couple of closing words in terms of, let's say, follow-up actions for yourselves, if you'd like. Luke, thank you sincerely. A great demonstration. Gabor, I'll hand it over to you briefly for any final words from your perspective and logic.
As I said in the beginning, we are very glad to be able to do this webinar together with WhiteSource. So it's a great cooperation, and we wish to proceed it. Thank you very
Absolutely. Much. Excellent. And I'll mirror those words. Thank you very much, Gabor, and thank you to Logic Technology. So final call to action, guys, really, for anyone that's joined the presentation today. Thank you so much for taking your time. Please reach out to us. The purpose of today's demonstration is really to take you through not only our partnership with Logic, but what our technology does and who we are. What we encourage you to do is reach out to us directly and request a one-to-one session. We have the capabilities of fully POCing our technology and allowing you to have your own independent POC process as well. We'll happily facilitate this. This is not a cost option. We will happily assist with the process and get you guys going. So please reach out to us. But without further ado, I'd like to end today's session. And thank you again to Luke. Thank you again to Gabor, and of course to everyone who joined. We really appreciate your time. Have a continued good day, and hopefully speak to you guys soon. Thank you.
Thank you. Bye. Have a good day. Bye.